Uh-oh, why is it not going through my speakers? There we go.
Hey Zach.
Maybe not. Hey, you are currently going through my speakers and on my headphones, so now I have to go figure out why this is not a.
Ah,
But how is everyone?
pretty good.
Oh, pretty good. Doing pretty good.
Excellent. Everyone had good holidays?
Yeah, absolutely.
Excellent. There we go. Why they make audio settings so hard for you to find? I do not understand. Someone talk.
Testing.
Thank God.
Testing.
Okay, we're good. That was really weird to get that set up, but
Got
ah,
it.
all right. Nice. Let's go ahead then and finish this book, and then we can decide if we want to do another book after this and what book that might be.
Sounds good.
All right. Share my screen. So we started at chapter 17, which basically talked about how whatever design decisions you make, you need to stick with them no matter what. You can't have one or two things that are a little different just for convenience on your end. Don't just uh, decide that you want to go do something completely different without good reason and only for one specific thing without fully stating why. Because when people are learning your software, they expect that you followed the same paradigm throughout the whole thing. That's why paradigms exist. And if you choose to just ignore them, then it makes your code base exceedingly difficult for users to just follow. When it talks about following existing conventions, when in Rome, do as the Romans do, right? So part of that is being consistent throughout your general code base. And the other half of that is you should be consistent in whatever a user is expecting out of the language you're programming it, right? So keep magic classes to a minimum. If you're using Python, stay Pythonic as much as possible. A very clear example of when that can be so difficult is fast core is really hard for people to understand, including myself, in a lot of ways, because it relies on a lot of Pythonic magic because it's inspired by a variety of different languages. And again, that's fine.
Is is that like the meta classes stuff, Zach? Is that what you're
Kind of. The meta classes is part of it. Jeremy does a lot. So Jeremy knows an insane amount of languages, and so fastcore was based on a bunch of languages. A lot of them are scripting languages and not object-oriented languages like Python is. And so it leads to a discrepancy in what the user expects, a lot of the times due to meta classes, but also due to just how classes are. Like the L class, we know it's a list, but it's a super powered list that has weird things that I don't understand what's going on.
right, right.
Or
So you would, I mean, the thought there would be use the list and make functions to do each of those things outside of like don't make a new class for that, use the existing variables and like if there's functionality that's needed, build it up outside of the
yes,
like to act on the native list class instead of making like a new list thing.
yeah, exactly. Like there's pros and cons of each and when you should. Like the attribute dictionary class, right? The attrodict. That I actually thoroughly enjoy as a concept. It's really good whenever you're writing an interactive like if you're not expecting someone to work in an IDE and you're expecting them to work out of Jupyter, it's really good for that. Like I brought that into a Hugging Face actually as part of the Hugging Face hub to document all the different parameters that one can pass in when calling the API. It's like model search arguments, and actually I can go ahead and bring that up now. Where exactly it's stored in here, I couldn't tell you, but let's go find out. And whether or not they're actually still in here.
I don't think I
Imagine-
knew that this was a thing. I don't think I've ever used this before. It basically
Yeah.
lets you index it like a dictionary or access it as like an attribute.
Yes.
Nice. I've wanted this functionality before, but I didn't know it existed in FastScore. That's nice.
Did they get rid of my model search arguments? That's gonna be annoying if they did. Author at me. Oh, that's why, because it's model filter. Well, no. I thought that at some point, yeah, it's FastAI uses it everywhere. Namespace argument for search parameters, attribute dictionary. Yeah, that's neat. Utilities. I wonder if they got rid of it. They might have gotten rid of that. Let's see if there's anything. Model search arguments. Ah, they did. Well, that's annoying. Well, it was there for a bit. In any case, I basically rewrote. I guess I could bring it up. Sorry for the random sidetrack, but basically what I wound up doing is, you know, that I dislike how magical some things in FastAI can be. So I sat there and decided what's the best way that I can write the attrodict in a way that users can understand. And so I rewrote it to just use Python spacing and a better repper. And that was enough where Sylvan was okay with that magic existing in the Hugging
What's
Face up.
Python spacing? What's that mean?
Actually using good spacing and not one line for everything.
Oh,
So
okay.
for
Just like
example,
how attribute dictionary is implemented there.
yeah. So
Okay.
like you see it there. Let me go ahead and show you the fast core version. readability is the word that I want there. I think it's under like core or basics.
Yeah, basics. It's basics.
Yeah, we'll go ahead and just bring up the source code so we can look at it. It's like 5 lines of code. And there's still kind of some weird things going on. So I just took that 5 lines of code and made it like 20 with an actual doc string. So that way people can follow it better.
Gotcha.
Now, sadly, this does not live up to the test of time, but it was not due to the fact that attribute dictionary was a problem. Also, nice cat.
Yep.
It was due to the fact that what we were using it for wound up taking a really long time to initialize because it would like literally pull everything from the Hugging Face hub. So I understand why they got rid of it. It was good for the time whenever it was small, but
Gotcha.
Yeah, okay, back to normalcy. So that's roughly what I have for chapter 17. Just please, for the love of God, stay consistent in whatever you decide to do. And make sure that you let your users decide what conventions you should follow on an actual deployed thing. So chapter 18 talked about how do we be transparent to the users and make sure that everyone can understand what's going on in your code. So first was about making sure that we're consistent. So now it's how do we pick good names? You should follow the rough standards for Python in this case. So don't capitalize the name of a function as the first character, right? Because generally that is seen as a class or at least an interface of some form. More people than just FastAI tend to abuse this. There was a library I was looking at the other day that wound up using title case, and I'm like, this is a function. Why are we using title case? To make it look pretty? I'm confused. So that's one aspect of it, and the inconsistency is on here. White space was also mentioned, right? White space acts as a separator in your code and allows you to split it up into what we would call paragraphs. It's a natural spacing as the user wants to read it. So use indentation in white space as you can. A good way of doing that is to use an auto formatter. At Hugging Face, we started with Black and Flake 8 for this, and then we switched to Rough because it's built in Rust and super, super efficient and fast. And again, white space goes back to the whole consistency part as well. Generally, yeah.
Is it on VS Code or
Is what?
the Rust based code spacer that you were talking about?
Yeah, what about it?
Is it in VS Code? Is it as
It's an extension in VS Code, but it's a Python library.
okay? So
So
it can be used via PyCharm and some other.
yeah.
Okay.
Generally, they've made plugins for this because Rough has just exploded in popularity.
Okay.
But for a general idea, so Rough is multitudes faster than other frameworks, and so generally there should be first-party editor integrations for VS Code. So there's a Rough VS Code that is a Rough linter.
Yeah, cool.
Yeah, it's an extremely fast, extremely popular linter now at this point in formatter.
Yeah, this looks good.
Yeah, and the good thing about being consistent with using tools like this is the rest of the ecosystem probably uses it too. And so now users can expect the typical white space that everyone else uses. Sometimes it's not perfect. Like, I think one general rule that people have is like either 69 or 88 characters per line. Some people follow that, some people don't. You can write your own custom rules. It just depends on how long you want the lines to be, generally. And I think someone did a study on what was the most readable version of that. And I thought it was something like 88 characters per line, but I don't remember off the top of my head fully.
I think so. GitHub also has a limit with respect to that. I think so. That's 80 characters. I'm not too sure.
80 is what it generally recommends.
Yeah.
Yeah. Yeah, there's it might be 80. What do we use? Let's go see. I think it's in this. Yeah, so we use 119
Okay.
in our code. Yeah, we use 119. Some people prefer 88. I think Stas bumped that up to like 130 at one point for some of his stuff. So it just depends on what you decide is best, and just make sure that it's not. You don't want it. The goal is if someone is looking at your code in just a standard IDE on a standard computer in 1080p, because most people don't run 4K, even though they should run 4K when they're coding. Make sure that the code doesn't go off the screen, basically, is the goal. So the faster they can just look at the code and scroll through it, the better, and whatever length that happens to be is what you should stick to. Comments, we talked about comments, I think, last time, being non-obvious with them and strategic. Be careful when using generic containers for things. So that's just storing like data in an array, but you don't name the array very well, which goes back to naming as well. Make sure that everything has a purpose, because everyone is going to want to read whatever code you have at some point in time, which goes to the next part of, so make sure that their life is as easy as you can make it. Because if you can make their life easier, chances are when you revisit the code 3 months later for a refactor or some other thing, you will be able to get a faster handle on things, because it's very easy if you just focus on the now to suddenly look at your code in 6 months and go, I don't remember why I was doing this, why this exists, or what I should be doing here. And then we covered red flags, look for any sort of problems that might exist. I believe every single red flag in this book has a section towards the end. So that in the end of the book, with just every single one of them listed, so you can quickly just go through and occasionally revisit them and double check that you're not doing anything that could be problematic. From here, I didn't really take too many notes. Chapter 19 just sort of talked about what the landscape was. So it talked about object-oriented programming and inheritance a bit. These were all filled in by ChatGPT. I did not actually write this. I just put object-oriented programming. So that was fun to discover. And then Agile, which Agile's good on large projects. Agile sucks on small projects, so I don't do it. Is basically what I've come to realize. Or at least doing the typical Agile development does not work for us at Hugging Face, at least on my team. So it's okay if you don't use Agile programming in what you do. Unit tests, obviously.
Yeah, in general, in machine learning projects, agile is fail. It kind of fails.
Yes. Yeah, and I think that's because Agile was generally designed for large scale system building, right? Where you have like 10 teams of like 20 people all trying to work together, which is not unrealistic scale. NVIDIA has a lot of large teams. And so
Mhm.
they have to work off of that for communication and management and everything else. When you have
Yeah.
a small team, even like from a non-ML perspective, right? Because I don't really do ML at work, I do software engineering. We have a team of 4 people. We don't follow agile practices. We have maybe one stand up a week if we decide that we want to talk about something. And then we just ping each other on what's going on. We don't actually follow a plan like this. So
Do you
it's
guys set goals every week, or like do
no.
you just
So
decide what you
it's
should be working on at the beginning of, like, once you're
the
done
day.
with the previous thing?
Yeah. Hugging Face is a very, at least the open source team is very self-management. So like, for example, one thing I'm doing now this year, but what I did last year is I kept a list of everything I was doing, sort of. Like we have a daily progress tracker that some people choose to use. I use it for just logging what I'm doing. Can you see Obsidian right now?
I
Probably.
I'm assuming so. It's a black with text on it. Says daily
Yes.
summary at the top. Okay.
Nice.
Yes.
Yeah. So I basically have a daily summary of what I do. And then I just basically maintain an issue tracker because my whole job is maintenance and then maybe some new features. So I just go through this issue tracker as needed and when I can. And that basically decides what I do that day. Which, as you can see, this was after filtering 250 issues when I came back from vacation. It's enough to keep us busy.
Mm.
So we don't really do the whole Kibana thing because, like, I can log it all here. And on top of that, my boss and upper management will be looking at the GitHub issues often and just seeing the overflow and backlog of them. So they can tell when stuff's not getting done or when stuff is. So that's why we don't really do agile development as much.
Do you share this with your boss too, or this
This
issue checklist? Yeah.
no, this is strictly for me.
Okay. Okay.
And then my daily summary I'm keeping for myself. When
Hmm.
it comes time for performance reviews, because we do them quarterly,
Mm-hmm.
then I'll go through them all. And as I'm writing my review, see if there's anything I need to bring in. But no one aside me really sees that.
Yeah, that's a nice workflow to have. Kind of you record everything when your perform reviews come out.
Yeah. And like on top of that, Clem has a very strong mindset of meetings should just not exist.
Mm.
And over time, we've kind of learned that, like, well, okay, we need to adapt no meetings exist to like some meetings might want to exist because some people need it. But having this no meeting structure and truly you are hired to do the work that we know you can do. So do the work and we're not going to block you. Those two
Okay.
combined leads to a strong trust in your company and your people because Lysander never comes to me and goes, "What did you do this week? What are you doing next week? How are things going?" Um,
Mhm.
he just trusts that things are getting done, issues are being closed, and he can see that, and we just move on with our day. And it's a very the word I want is we don't micromanage a Hugging Face, and more people need to not do that because you don't need to know absolutely everything that's going on. The role of a manager is not to know absolutely everything; it's to know the critical things. And as you go
Mhm.
higher up, that matters even more. So, it's I believe it's worked quite well. It's had some issues for some people, but overall, it does a decent job.
Mhm.
Okay, so next, unit testing and test-driven development. Uh, make sure that you test your stuff. The general rule of thumb that I use when it comes to unit tests and test-driven development is can't remember if it was this book that said it or another book, but at one point I heard the number, you want to be about 60 to 70% of your code base to be tested in terms of what we would call code coverage, right? How much percent of your code base do your tests actually cover? Because the more you test, the more friction you add whenever you want to change things. So you want to balance getting the core things good and making sure that they're stable and tested, but have enough wiggle room to where you can change things and not have to rewrite like 50 tests. So that's just a general rule of thumb I have with test-driven development.
I thought
Mhm.
the part that I really agreed with that section was you should add a test before you write the code when it's a like there's a bug report about that specific code, and you need to make sure that it does like that you're
Mhm.
actually fixing the code, because I've had that problem where I don't write the test before, and then I'm like, all right, there we go, write the test, and it passes, and then I go and redeploy it to production, and the same bug is still there. It's like, oh, I would have known that if I had done that properly and like created the test beforehand.
Yeah, to that aspect, I agree with writing the test beforehand. I do a mixture. I generally don't write the test beforehand, but I think of what I'd want the test to be. Bug reports, though, pretty much always become tests because it is a
Yeah.
known failure case, and like you can test for that. Now, do I write the test before? No, but I make sure that the test is in there as part of the PR.
Yeah. I actually do that. I write the test before I write the fix to make sure that it fails, because
Mhm.
I've burned myself too many times not doing that, and like thinking that I fixed the bug and
Mhm.
then realizing that like, oh, it's like skipping that if statement, or like it's not
Mhm.
actually getting to the piece of code that I think it should fail on, that it's now passing. It's like, yeah,
Mhm.
it's just not hitting that case.
Yeah, most of the time that works out quite well. Um, the tricky part with Accelerate and how we deal with things is writing a test that actually works sometimes is near impossible. Like right now, we're dealing with an issue in Transformers where essentially someone made it like the concept of it made sense. When we save the trainer stuff and save your model, save it in a staging directory first to make sure that we don't hit any issues, and then move everything to its actual ending result. It worked perfectly fine. Every test passed. Except all of a sudden, I wake up the next week and there's like 40 issues filed because it completely broke multi-node. Well, I don't have a testing thing for multi-node. So it's like it's exceedingly difficult for me to write a test for that. So I just can't. And I have to rely on what my users tell me works or not, which sucks so much.
Yeah, I mean, how can you even how do you support that? Like if
Mhm.
it seems like it's really hard to even like support something that you can't at least have a test environment to actually show that it works.
The way you do that is you trust the people that are putting the PR in for the support that they'll go through and do the testing. A very good example of this is so Accelerate supports a variety of accelerators. Accelerators meaning devices, right? So we support CUDA, we support CPU, we support XLA, we support what's called NPUs. We don't have access to NPUs to test it. So we trust that I believe Intel folks, I could be wrong about that, but the people behind the NPUs, they did the implementation. If we see any issues, they deal with it. And it's sort of a trust aspect there. However, the second that breaks, if they stop doing that, right, we're just going to free support for that because we can't test it. So it's sort of a
Yeah,
risk in that way.
right.
Um, And we chose that like having Accelerate be able to, hey, let's have it support NPUs because now we can support NPUs across the Hugging Face suite. And anyone that uses Accelerate, it's there for them with the understanding of we are not going to baby this integration. If it fails at any point in time and they don't maintain it for us, like it's just going to stop.
Yeah, you're not spending your clock cycles on keeping that up to date because you
Yes.
don't have the ability to prove that it still works.
Yep.
That makes
and
sense.
the general hope is that if
I mean-
it does enough and it gets to that point, then whoever built it gives us access to runners for us to then go
Right.
test them.
Well, and that's also where open source has the advantage of like you don't have to maintain every corner of your code base. If somebody wants to add support for something, like in theory they can, as long as whoever maintains the code base is willing to accept that, you know.
Exactly. And it's like generally the rule with open source is you never want to say no truly to whatever's going on unless it's something that's it doesn't make sense for it to exist. You never want to say no. You always want to help them get to the point where you can say yes. Right? Because whatever a user brings to you as part of a PR, it exists for a reason, and they have that reason. So if it makes sense to then have that in there, do it. Right? There's very few PRs in Accelerate that we have had to say no to. Like the biggest one was someone completely rewrote our testing paradigm to make it device agnostic. We spent like 3 or 4 weeks with them on this PR because it started in a way that I saw as just completely unmaintainable and got it to a point where it's like, okay, this makes sense. Let's do it. You know, that it doesn't help us per se because we just have GPU testers, but now this makes everyone else's lives easier because they can test on NPUs and whatnot. As long as we can maintain the core that makes that go.
Yeah, I get what you're saying with like not saying no. I mean it should overall it should strengthen your code base to not, I mean, definitely not to just flat out just reject. I think sometimes the risk there is it's going to add complexity. So, I mean, is there a way to generalize your code to, you know, be able to allow them to build on top of it, or like, I think that's kind of the other alternative of like, okay, we don't want this directly in our code base, but we want a way to like for you to interface with our code base. That'd be the other alternative.
Yeah, and we see that quite often whenever some people go like, hey, I have this concept for this thing. It's like, well, it doesn't quite fit in Accelerate, but if you integrate, like, we'll include a link to it in the docs.
Right. And that's also not a no. Like that's
Yeah.
kind of still follows what you said initially.
Yeah. Like there's a number of things where it's like people have come to us with ideas and it's like, well, okay, we're not ready for this now. Keep going, build your library, and then we might rely on it. Like, right now in Accelerate, we're actually working with the PyTorch team on pipeline parallelism. So basically allowing you to do inference on large language models when you have offloading, right? Except rather than doing one batch at a time, because it has to go through and offload everything, you can do up to n GPU batches at a time. Because
Is that
GPU
using their data pipe stuff?
Yeah.
Is that actually that's
no, it's not using data pipes. No, it's using something
okay.
completely different. It's a library called Pippy.
I think I've heard of it. I haven't used it.
Yeah, you'll see me talk about it fairly soon. We've been working very intimately with the Torch team, and they've been showing that they want to support Accelerate, and so we work with them very heavily on, hey, we tried this thing, it broke. The next day, like, they have a fix for us. So because of that, like, we're probably going to get to a point very soon where Pippy is just going to be a required dependency of Accelerate, because the pipeline parallelism they have works quite well. And we looked at pipeline parallelism before, and it's like, well, okay, if we have to like figure this out all ourselves, that's going to take a team of 4, like 6 months. Or we can have someone else that does it for us, and then we can decide, okay, do we want this to be an optional dependency or an actual dependency? And regardless, either way, like, we've now integrated with you. That's a win.
I know where I saw it. It was you. You showed it a couple weeks ago.
Oh, got
it. You showed where you're exploring it.
Oh yeah, nice, perfect. Oh yeah. Yeah, it's vacations, man. I forget some of that code is.
Yeah, it's like a month ago now.
Literally. Yeah, okay, so now I think
I felt like the main, I was just gonna say, I felt like the main concept of chapter 19 was like, okay, new trend comes out, like ask yourself the question, does this make my code more or less complex as like a first pass of should I be doing, should I follow this? Is this a good thing for me to consider adding to my GitHub repository?
Yeah.
Like, is it more or less complex?
And like that's kind of how I deal with the ML field right now as well. Like, I don't pay attention to it a lot because a lot of it's noise. What I generally do is I'll wait 3 months, and then whatever's still like, oh, this is actually a thing, we need to look at this, then I'll go through and learn it. Like now I'm learning RAGs because it was a big thing last year, but a lot of iterations of whatnot was happening over it. And so now that it's kind of stable, I'm finally going through and learning RAG systems because it's been around and people are using it. And so clearly, like, this is good and we should use it. And generally, like anything, be it either code or something you learn, like that's a good way to think about it. Of, does this make things worse, or am I just going on the hype train? And you never want to just be going on the hype train for the sake of going on the hype train. So the last chapter is, or at least the last chapter I have notes on, because I skipped chapter 20. I don't think I found anything useful or interesting in there. Is basically how do you decide what matters in a code base, right? How do you decide if this new feature actually has the strong impact you're looking for? Or is it less critical and it's neat, but it won't actually provide humongous benefit into what we're doing for? So the first thing I recommend is looking for leverage. So identify where this solution exists and double check, does it solve just one problem or does it solve many? If it solves many, then that's a really good sign, and you can start to entertain this idea and look into how this could wind up working. Make hypotheses. If you're not entirely sure A versus B versus C, and if a particular idea is better or worse, pick one. Just pick one. Hypothesize what you think is the best. Explore it as far as you reasonably can quickly. And then from there, figure out if a hypothesis was right or not. You know, it's going to take time. The book mentions a lot that things do take time. We want to minimize it as much as possible, but some things you can't avoid, such as finding out if this idea fails, because you're not going to get it right the first time. So make that hypothesis, learn from what happened, and use that to build future iterations of what you're thinking about, right? Iterative learning and iterative programming as well. And then minimize your parameters and important places. So what this means is when you write a library and you write an interface, every single line of code should not be the most important thing, because that's a lot of things for you to wrap your head around and think about. In the case of Accelerate, there are 3 critical places that we have: the accelerator class, the big modeling Python file, and our CLI. And those are the 3 most important places: one file, one class, and roughly one section, but it's all CLI. Everything else is either utilities, extensions, support for other things, but those are the 3 core parts. And everything else then builds upon that. If everything mattered and breaking one thing broke everything, because that's what that would essentially mean. If everything has the highest priority, everything has to rely on itself and everything else. Then you have a fixed system. Users get overwhelmed because now they're sitting there going, well, I expected like to just have to learn 1 or 2 classes to use this library, and now I have to learn the whole thing. It makes your code base really confusing and overwhelming. So try and minimize that as much as possible. How many that is, I couldn't tell you, right? Because if we think fast AI, I would say the learner and the data classes, right? So there's like maybe 5 or 6. Sometimes it's overwhelming, but 5 or 6 is not too bad. With Accelerate, it's 3. With Transformers, it's generally, if we think the core parts, 2. Auto model and the trainer is kind of what I would say is the core part of that. Maybe 4 or 5 if you start going like into detail with the auto model. So make sure that you always minimize the number of parameters people need to know, the behaviors they need to know, and the places they need to learn. Because otherwise, like, that's fine if we have a super small project. Like if it's a super small utility-based project, yeah, everything can matter because every utility matters in that extent, because that's why you're building the library. Suddenly scale that up to like 1,000 files, it's unmaintainable. And so that's sort of what this section harps on. Make sure it's small, compact, focused, and users and yourself don't get overwhelmed with things. All right, so, and it lastly talked about common mistakes when doing this, right? Treating too many things as important. Everything that you write is great. That's what you're going to think. Everything you want to write, you should have people use. That's a general thought. But simplify it as much as possible whenever you're writing the end user's tutorials, API, documentation, because otherwise you're just adding to the complexity, adding to overloading the user's knowledge, and raising the expectations of what's needed for a user to do this, raising the scope. And then on the other side of that, things still need to be important. Even in a utility library, if we say, well, it's just a utility library, nothing matters. You should still find a few things that are important that generally are the reason why you made this utility library, right? If your first instinct was to do that to wrap around some CLI utilities, then that's the important part, right? It might have expanded into other things that help build on that, but the core important part is the CLI utilities. So
I mean, wouldn't that if it ended up at the end, you're like, none of this is important, then you should just get rid of the library at that point, right? Like,
yeah,
like if you have a util file or whatever, it's okay to delete things.
If it was at that point, I would store it in a GitHub gist and just be done with it. Like, it doesn't need all this extraneous stuff. Just leave it how it is. Or you leave it in a GitHub repo, write some light documentation for everything, but make sure that generally it's set up high if people want to use it as a library, and make sure that the code is documented more than anything, because it's, if you do that, users then generally will know, like, well, okay, there's not real documentation for this. It's kind of a personal thing. But still make sure that you write the code well, so that way if they do go explore it, like, they understand how to do what you're doing and use it, because they might find it useful. And that's kind of the end of the book there. That at least I have in my notes. So overall, my general thoughts on this book is, and why I sort of chose it as the first one, it's the first level-headed approach to programming that I've enjoyed, where it's very realistic, right? Even though it was made by, I believe, someone at Google, it's a practical approach to programming. And at least where most of us come from here, we got learned on practical programming. So we want practical ideas that scale down to a single person and up to, hundreds of people. So, and it also used ideas that I was taught in school and also conclusions I generally came to. So in a way, it was like acknowledging that, hey, these weird ideas that I have aren't actually weird, and like people recommend doing them.
I
So
think the author is actually a Stanford professor. I don't think he works at
Stanford
Google.
professor, thank you. Yeah, I got it confused with the Google talk that I posted in the chat or
Yeah.
someone did. Yeah,
Yeah,
Stanford professor.
he spoke at Google. Yeah, correct.
Thank you. Yes.
Mm-hmm.
So those are kind of the reasons why I picked this book. I'll give us a few days. Think about what other books you want to read. Have an idea, let's say by Wednesday, and I'll put a poll out. I have a few books. At one point I got framework design guidelines, but that was more for .NET and does not really apply to Python. And a lot of the stuff that I found in it doesn't really work very well to what I experience in the day-to-day. We can go through high performance Python or software engineering at Google. And then I also have head first design patterns, which is a much thicker book, but I'm open to going through that. Otherwise, right now I'm also reading a few software engineering management books if we're interested in that route. So I'll post all of it in the Discord. If you guys have any books that you want to read, also post them in there. And then I'll put a poll out probably by, if we have all that in by Wednesday, I'll make the poll Wednesday and then give us like a week buffer. So we'll do the next one 2 weeks from now, just that way people can read through the book of whatever we decide. Does that sound reasonable?
Yep, that sounds good.
Awesome. Any other thoughts before we end the session a little early?
Yeah,
I thought the book was really good.
yeah, I enjoyed it. Specifically, the chapters with had writing those codes and more modifying that code with respect to how those patterns can be used further down the line.
Yeah, it's that is like one of the specific reasons why I picked this book, because it's a lot of them like cover, here's how you code well, here's the rules for coding, here's like, use white space limitingly. It's like, well, no, here's the idea, here's the concept, and here's a level-headed reason as to why we're doing this thing. And here's an example of why that can be bad and what happens.
I think this book has a lot of like first principles thinking to it, so that you can like, I mean, there's always new ideas and new things that are, even like new IDEs and stuff that are popping up, and it's like, okay, should I be using this? Like, let me kind of think through, like, well, is it going to help me reduce complexity? Like, is using Copilot to help me write code, like, will that help me, follow design patterns better? Should I, consider using this to reduce overall complexity of my system?
Totally. Yeah, it's definitely helped with how I look at new tech, as a much more, not necessarily heightened skepticism, but like, I understand the problem you're solving. How big of a problem is that in my life and in my coding? And should I go learn a new system that could like vanish at any moment and go do that? When I got started with Copilot, that was the big thing for me. It's like, well, okay, I shouldn't use Copilot. I don't want to use Copilot. And I started using Copilot for a bit in the early days. And now, like, I can't program without it, because even though Copilot isn't the best IDE programmer, right? I understand its behaviors and it works for what I need it to. So I don't need to go, host my own LLM or, go look at GPT-4 and whatnot, because it gets the job done. And that's all that matters at the end of the day.
Yep.
So
Regarding the design patterns that you glossed over in chapter 19, Yeah, I was in my early in post engineering days, I was with the Java community. So yeah, those getters and setters and those as you might have seen in the head first
Mhm.
design practice book that is in Java. So I had a lot of hand in writing that patterns code with respect to all those creational, structural, and
Mhm.
behavioral patterns that they describe in the Gang of Four. So from that, I brought my my thinking to Swift and Objective C, and now to Python. And I
Mhm.
truly see a huge paradigm shift between what Java used to do and how Swift and Objective C had those patterns with, and now with Python. And since I'm more involved in the research community right now, and I see codes that are morely in a form of a script in Python way, in a Pythonic way, the original and the Python 2 way, in
Mhm.
which those not much object oriented code and not much user design patterns. So there's a clear shift between a paradigm shift between what those things are right now, and uh, how people write code with in the research community with using those open source libraries from Hugging Face like Accelerate, Peft, and transformers, etc., with the Hugging Face hub too. So yeah, that's what I have seen, and I would like to kind of continue this journey.
Yeah, and I think like I have a fairly reasonable idea as to why that is, because generally researchers take an intro level Python course, an intro level programming course, and then go with that and figure out everything else on their own. And there's a ton of different resources. And so if general researchers don't have that good of programming skills to begin with, they're going to borrow bad practice from everyone else, which leads to that, where everyone's like using a chunk of everything else, and it's like, well, this is not clean. Um, and so like that was why when originally it was a priority for me to write that software engineering course, like that's why I wanted to do it, because I know researchers and they're depending on where you went to school, I should say. Um, some researchers' experience with programming is very small and limited, and generally has just a few practices. Like, Jeremy recommends taking his course after taking a year's worth of Python. That's not going to get you as far as you need to say that you're a good programmer. You're a decent programmer, and then you go learn something that has a lot of confusing practices. So, at least right now, it's not a plan to do that, but I might share some resources. I don't know. But that's also why I wanted to do this, because the Walk with Fast AI course was very machine learning oriented. Now let's have a study group that sort of can bridge that gap to make you stronger.
Yeah,
So
true. It does that to a much extent.
perfect. Then we're doing excellent. Thank goodness.
Yeah.
All right.
We are
Awesome. Mhm.
yeah, we are on the right track, I just.
Perfect. Thank goodness. That's as long as it's worth it and everyone's enjoying it and having a good time, and at least there's YouTube, it is worth doing. So, all right, I will post a link to the recording in Discord some point today whenever it gets uploaded, and then I'll post a few books that I have. Write down any more that you want in book recommendations, and then I'll do a big Google poll with what we should do. All right?
Maybe you could do a Twitter poll too. Uh,
Yeah. Oh, yeah. We can do a
or
Twitter poll. Totally. We'll
yeah.
do the beginner poll just to get an idea, and then I'll
Hmm.
filter it down a bit, and then go to Twitter and see what everyone else recommends too.
Okay.
So
Yeah.
awesome. Good
Yeah,
idea.
that's a good idea.
Yeah, that's a very good idea. All right, cool. Thanks,
Sounds
everyone.
good. Thanks, Zach. Thanks,
See you in
Mayak.
a few weeks.
See you guys.
Yep. Thank you. Stay here. Bye.
Bye.
Bye.